Guys, let's go over some of our design lab implementations on the course page using Packet Tracer. We're going to be using Packet Tracer over here for this lab demonstration. So generally, Cisco Packet Tracer happens to be technically it is a simulator. Some people call it an emulator. I think it does both. It simulates and emulates a complete network uh, as you would actually find it within a physical environment. So, like for instance, if you wanted to build a system, a network system, and test it out to see if it conforms to a given scenario that you want to deploy, a good application to use to simulate the network and emulate some of the key physical environments that you're looking at before the actual implementation will be to use the Cisco Packet Tracer. So it happens to be a cross-platform visual simulator tool, which was designed by, actually it wasn't designed by Cisco, it was designed by third party and Cisco bought it because they realized it simulated or emulated most of the key elements and key device system of most of the Cisco appliances or Cisco network devices. Um, so yeah, Cisco bought it because, like I said, it looks very good to them. So they bought it and they've upgraded it over the years, and it's practically becomes their application now. And Cisco Packet Tracer now. Um, the softwares allow users to simulate and configure most of Cisco routers and switches. Um, Use some of the key command line interfaces or operating system interface commands that Cisco employs on the devices. So, like I was saying earlier on, if you wanted to build a system, this is a good platform to test it out on first. And when you address all the key challenges that you envisage, then you can just carry the commands onto a physical device for the production system itself. Cisco is not the only um, uh, vendor or manufacturer out there with a simulator and emulator software. We also have Huawei's, which is the Huawei uses the ENSP, which is this right here. Basically the same setup, um, and it practically the same thing. This also simulates and emulates most of Huawei Cisco systems and environments. So they're pretty good applications to use if you're going to be a network engineer. These are some of the applications that you could play around with before you actually set out to go the implementations on the production system. At least it also helps you get an idea or an overview of how much budget you're going to be needing for a particular project, some of the challenges you think might come up, and how you want to address them before you actually set off. Okay, and we also do have another one for Cisco, which is the or another emulator simulator, um, by a third party company that emulates or simulates or simulates or emulates whatever you want to call it. Cisco environment, which is the GNS3, another good example. I would probably say GNS3 and the Huawei ENSP are practically closer to design implementation or simulation wise as compared to the Cisco Packet Tracer. I think these are much more, they give you much more real, the GNS3 and then the ENSP from Huawei, they give you a much more feel of your various vendor system platforms or environments much better than you would with the packet tracer. But I might be, a bit uh, biased about it. Whichever one you use, you have a good feel of it. But I feel like if you want to go professional, uh, GNS3 and the Huawei E and SP are the two ones you want to be looking at. By the way, so the ENS is purely for Huawei, and then the GNS3 is purely for Cisco. But for beginners, Cisco Packet Tracer is like it's also a good platform to start out with. Yep. So with that said, let's just dive right into it and see some of the key things that you expect to see within the platform. This is going to be a design environment, the interface that you're looking at. It gives you both the logical and the physical. And just like any other application, you'd have your file, your menu bars. And down here are some of the devices that relate to Cisco network equipment. So when you click on the first icon, you should see network devices ranging from your um, routers from the 4000 series, 1000 series, or the 1900 series, 2900 series, 2911 series, to your VPN routers, the 800 series. No, I mean the 2000 series, the 2900. So we have from the 800 series, the 1900 series, to 2900 series, and 26 as well as the 43 Henry series. Usually Cisco goes by some of uh, the numbers of their devices as the series names of their routers. So you have for the VPN for branch offices, you'd have the 800 series, which would encompass some of the H29 versions, and I think H30s. And then for medium-sized organizations, you have the 2911s. Small enterprises, your small businesses, you have the 1900 or the 1841s. And then for the upper grade or high end levels, you're probably going to go for the 43,000s and the other higher number series. Good. And the second icon relates to end devices. So this is where you can find your PCs, your laptops, servers, printers, TVs. They've been able to incorporate a number of the key end devices that you find within most business environment or work environments. So you can be able to simulate them or kind of like emulate them, better or in real life at least. Okay. And then you do have your components for boards, which is more related to your physical boards of your devices, the integrated circuit parts. Your cablings are over here, or your connections. You have your auto cables, and then you have your serial cables. You should have your so it's automatic choose cable connections. If you want to just go automatic, you can use one of these guys. If you want to go much more, uh, specific, you have the serial console cables that you connect to the device and it connects to your PC or your laptop to do configuration directly, physically or whatever. And then you do have your straight through cables, your crossover cables. The names of the cables will show up at the bottom over here, so you can see. And then you have your fiber optic cables, the phone jack cables, coaxials, your serial DCEs, and then your obviously your serial DTEs will come in. Octals, IoT custom cables, and then your USBs. And files, that encompasses some of the basic systems that you use on a regular basis. And then finally, your multi-user connections that mostly relates to your cloud environment. So you can even emulate the cloud, which is quite interesting. You have the cloud emulator over here. Um, Great. And then down here, obviously, which is just about the same as whatever you're going to see over here, but more in depth, one of the key physical ones, you have your routers, your switches, your hubs, your wireless devices, and your security appliances, and obviously your one emulators. So you do have your switches, the 2960s. Really good switch over here. I like using these guys a lot. For a 24 port switch. They do have the 16 and 8 ports as well. Your hubs not widely used, but still usable. Your wireless devices from the Meraki's all the way up to your home gateways, your wireless home gateways, which some of you should have in your businesses, organizations, or in your homes. I used to have the Linksys Cisco wireless router. I use them a lot for most small businesses setup or homes. But these days I've more or less switched to the higher grade ones from Ubiquiti and all that, enterprise grade ones. Um, anyway, so your wireless setups are going to be here for Cisco devices, and then your security appliances, mostly the 5500 series, the Aces or um, uh, the Cisco security appliances. So great. You have these also. Basically, these are some of the icons you're going to be playing with in terms of your setup for your network environment that you want to simulate. So let's start with a simple one, a basic one. We want to use. Uh, Let me start with the switches first. Just interconnect devices first before we add a router, because generally routers are designed to let you forward packets across networks. So if we're really not interested in forwarding packets yet, there's no need to incorporate a router yet. So let's just hold on to the routers for now and start with their switches and end devices. So I'm going to go with the 2960. So I'm going to build two separate networks. If This will probably revolve around segmenting two networks if you don't want to go with VLANs or virtual local area networks. You just want to go physical, then you're going to have two physical switches to create the network. And then we're going to add our end devices. So let's go to our end devices. Where are you? End devices. So you have an organization with two units that are maybe a bit apart, and you want to interconnect them. So this is unit 1 over here on this side, and another unit on this side. So let's just add some PCs over there, some end devices. I got two PCs on this side, and two laptops. Oh, sorry. And the same applies to this side. We're gonna have two PCs, maybe one laptop here, and then a server on this side, as well as a server on this side. So yeah, we have two separate units with their own, uh, setups. So let's say this could be probably be this say let's say this unit is maybe your HR department. It has its own server that runs some of the HR servers, and then we have another unit over here that has the maybe the finance unit, and it also has its own finance software run on its own server. Okay, so now that you have this, we need to connect them together. So anyway, if you want to add the device, you just click on them and pick and drop practically. Just pick and drop in your network environment or your simulation environment. So after we're done with that, we need to interconnect the devices together, and that's what we're calling connections. So I'm going to connect two devices that are on two different levels of the OSI model or dissimilar. We have a switch and PCs, so dissimilar devices and the connectivity requires you to use a straight through cable. So I got my straight through cable, and I'm going to connect. So to connect the switch, you just click on it, and then you see all the 24 ports. It has 24 ports and two uplink gigabit ports. These are your uplink ports, which are used to connect higher devices. Like for instance, I want to connect to a different switch or connect to a router, then I'll use the uplink ports because they have much more high throughput. This is 1 gig, and the 24 ports are fast Ethernet with 10 by 100 megabits bandwidth on them, whereas the gigabit has got gig bandwidth on them or throughput on them. So to connect, you just click on a particular port. So kind of like you connecting a cable from the switch to the PC or to your end devices physically. The same concept. So by clicking on it, you have a cable port connected, and then you go to your PC and you connect it to Ethernet port as well. So now you have these two ports connected. Okay. By default, Cisco switches come with their ports already enabled. So once you hook it up, it's good to go. Or once you power it up, it's powered up. The interfaces are all on for you to connect the cables to. So as time goes by, it will start going green to indicate that there's transmission going through from this PC to the switches or the PCs to the switch. So I'm going to connect all of the PC, all the devices, just picking the various ports that I have. So as you notice, this is all green now, means everything's connected. This frames in transmitted across. And then finally we hook up our switch as well. And we go to this side, same concept. And then you have your server on the side. Okay, so I'm gonna put some notes over here. This is where you apply your notes. So this is gonna be a simple uh, LAN setup. Yes, involving two business units. Uh, let's say this is your HR department. And this would be your finance department. It could be IT, whichever one you want to go with. Finance department. Okay, so this looks good. I like the way it's set up. So we have two separate units, and let's start with just one unit first, and then we move on to how to connect them together, since they're going to be separate networks. So let's start with this first. Now, in a setup like this, if you do not have, or from at this point, you want to find a way to get the device to actually talk at the layer 3 level so they can exchange information back and forth or transmit information back and forth. And to achieve that, you need to have what IP address on the devices. Now, if we do not have, if you want to basically have an IP allocation to your devices or set up for your devices, and you don't have a DHCP server, which is your dynamic host configuration, to handle the dynamic IP allocations, then you can go static. So you can assign IP addresses either dynamically or statically. Statically, it's mostly manual. You pick an IP subnet group, class, subnet group you want to go with, and then you start assigning them manually to the devices or statically to devices. Uh, but if you do have, want to go dynamic, which is where you have to invoke a DHCP server um, to help you automatically assign or lease IP addresses to devices within the network or the department unit that you want to set up. So we're going to go with static first, and then we'll configure DHCP on our server over here for dynamic IP leases. So within this, to set up the static IP address, what you do is just like you do for your physical machines. You go to your network, so you go to your network sharing center, your open network and internet settings or sharing, whatever it is for you. And then you go to your network adapters, and then you go to the properties of a particular interface, and then you do the static IP assignment. With this, the same concept. If you want to do the same process or emulate the same process on this environment, on the Cisco simulation environment, you click on your device, and you have this window pop up telling you the physical interfaces that you have on your machine. So you have look at even the view of the machine. It gives you CD-ROM, uh, your floppy disk. This is practically an old uh, icon that you have. But anyway, it's just a simulation. And then you have the configurations. It tells you the various settings, the global algorithm settings, interfaces, Bluetooth setups, and what have you. And what you probably want to be focusing on now is the desktop, where you have all the various icons to click on. So you do have your IP configuration. So this is where you find your network and sharing or settings from. For dial-up, you do have dial-up icons. You have your terminals, and then you also do have a command prompt for Windows environment. You do have a web browser as well, access point, VPN configuration, traffic generators, um, MIB browsers, Cisco IP, communicators, email, um, PPO, sorry, PP, point-to-point power over internet, dialers, text editors, firewalls, blah blah blah. A whole number of key features that you can use as on your desktop to simulate your network, your setup that you have. We want to go with, for the IP static assignment, we want to go with the IP configuration. So just click on it. You do have other menus by the programming and attributes, but let's just start with this first. So over here you have your DHCP or dynamic configurations or dynamic lease of IP address, and then you have a static. So we're going to go to static first, and then we'll come to dynamic later after we configure our DHCP server. So we're going to go with for the IP classification, we're going to go to class C IP address, and on a much more lab environment, we'll go with the private IP address of class C IP classification. And we're going to go with 192s, 168, maybe 1 dot, I'm going to use 100 for this PC here, and by default, class C uses the /24 subnet max. So once you click on it, it should show up. We don't have a gateway yet because we are not routing packets out of our network yet, so we don't need that now. When we do have a router in place, then we can go for the gateways. So for now, no gateways. And then once you're done, you can just close it. So that has been basically set up on this machine, and you can check by just putting your cursor on the device, and it should tell you have your Ethernet with an IP interface which is app with an IP address that you set. No gateway, no DNS yet, all that good stuff. Not there yet. Let's go ahead with the second PC. Desktop, IP configuration. So 192.168.1.101. Because the first one was 100. And then the third one, 192.168.1.102. So this was 101 to 102. Okay. And then servers are always static IP assigned. A server should not have a dynamic assignment. It just wouldn't make sense because servers provide specific services to a given network. So we don't want a situation where their IP addresses are dynamic, where they change on a regular basis. It's kind of like having a house with an address that change on a regular basis, as and when it feels like it, or uh, it, um, it acquires an address. That would make the locating that house very difficult because today it can have this address and then tomorrow a different address. Quite difficult to track the house. So usually you don't want to have servers with dynamic IP assignment. They should always be static, okay, because it provides specific resources on a given network. So they have to be always statically assigned. So you can always, without changing, so you can always reach it whenever you want to at any given point in time. I'm going to use 192.168.1.10 for this one. Cool. So we got that. Server is up. That is an IP address as well. By the way, you can also change the names of your devices by just clicking on it. So if you don't want to name it, or if you don't like the default names, you can change them. So I'm going to say maybe finance server, fin as VR for short, finance server. This is PC1, PC2. Anyway, you can change the names if you want to. I think it's a fine. I'm just going to change the server names to to indicate that they are for a given unit. So this is HR server and this is finance server. Okay, so now we've assigned IP address for this part of our network or part of our network unit or department. Let's see if we can establish communication or check if there's communication between the devices that are interconnected on this network. So to do that, you need that famous network command, which is your ping. The ping command is used to check if devices on a network are connected or not, or are alive or dead. So if you're a network engineer, or even just more or less, if you just a network guy or an IT guy, let me just generalize an IT um, officer or an IT professional, what have you, or even a beginner, and you've interconnected systems, you want to troubleshoot to see, maybe assuming that you have some issues with connectivity, and you want to check to make sure or to find what exactly is going on. You want to identify what the problem is, why you can't reach a particular device. The most typical command to use is the ping command, and you can get it from the most operating systems. For Windows, you have the Windows command prompt. For Linux base, you'd have the terminals. So let's click on this machine, and then we go to either one of these guys, but this is mostly for The terminals are mostly for Linux-based machines. You can also use this